Good morning, guys. We're starting a new chapter today. So we're talking about limits, which I think is a pretty fun topic. So we'll just jump right in. So first, we want to define what a limit is. I'm gonna move my coffee. Classic. It's in my way. All right. So first, let's define what a limit is. Okay. A limit is simply a value that a function approaches. In other words, it's asking what y value does the function intend to have, the keyword there is intend, for a given x value. So it's going to give us an x value, and then we're going to figure out what y value we're going to get. And so this right here, the y value, is what the limit is approaching, what y value. Okay? There are three different ways that we can find limits, and we're going to spend time on each of them. So first, we can use a graph. That can sometimes be complicated visually, but it's a really good way. The second thing we can do is we can use algebra or properties of algebra. And then the third way is we can use a table. Now, we'll have to use different methods sometimes for different graphs because it doesn't necessarily work for every single one. Okay, so for our first example here, we've got a graph that we've seen millions of times at this point in our math career. That's a little boring. Okay, so we have f of x equals x squared. I'm going to go ahead and graph what that looks like. So we have 0, 0, 1, 1, 2, 4, 3, 9, and then it gets reflected over the axis of symmetry, which is just x equals 0. And so this is our graph of f of x equals x squared. Okay, and so jumping in, this says what value does the function intend to have at x equals 2? Okay, so this right here, this is the limit of f of x as x approaches 2. I'm going to zoom in on that a little bit so you can see it better. So limit of f of x as x approaches 2 is how that is read. So what this is asking is what value does the function intend to have at x equals 2? So if we were to look at our graph right here, here's x equals 2. There's that line. Okay, there's a line x equals 2. And the function, you'll notice, has two sides because it goes on forever. So it's going from the left, it's approaching 4, and from the right, it's approaching 4. We want to squeeze it like a pimple. I know that's kind of gross, but you won't forget it. So we squeeze the function like a pimple approaching x equals 2, and we get that the function intends to have a value of 4 where x equals 2. Okay, so just like that, when it asks us where it's approaching, we just squeeze the pimple. And then we'll see cases in the future where we'll squeeze the pimple and they'll move past each other like this. And so it ends up not having a limit. Okay, so just some quick vocabulary, or more just definitions as far as what we're going to talk about. So we've got a function. So we have limit as x approaches 2 of x squared equals, cap these because I'm marking out my hand, equals 4. So I just rewrote the function that was up here. Okay, this can also be written as the limit as x approaches 2 of f of x, like that. Okay, so we might not have, it might give us the function like it did up here, and then we kind of have to fill it in, or it might just give us the function straight away. It really just depends on the problem that we're working with. Okay, so this little number right here, this is the value, the x value you want to evaluate the function at. Okay? Then right here, this is our function. And then finally, over here, we have our answer. Pens are rolling away. Okay, so those are kind of our definitions there. All right. Okay, so we're going to look at some more examples, just flipping over to the other side here. Okay, so these were one-sided limits down here. Or no, I'm sorry. These are two-sided limits. Okay, and now we're really going to jump into what a two-sided limit is. Okay, so in order for a two-sided limit to exist, the function must approach the same y value from both the left and the right. So that's what I was talking about before, where we want to squeeze that pimple and our fingers should meet. Otherwise, they're going to slip past each other and the limit doesn't exist. So I'm going to draw a function where they're going to go past each other, okay? So we'll just put, just draw something random. It's a little sloppy, but it'll do. Okay, so we kind of have our function here. All right. Okay, so we have a piecewise function. I think I spelled piecewise right, but I am terrible at I before E rules. Just can't figure it out. All right, so oops, see daisies. Okay, so let's look at the limit as x approaches 3 of our function f of x. So we'll call this function f of x here. Label is important. Why does it keep going out of focus? Don't appreciate it. Okay, so let's look at it. So from the right, we'll start from the right, moving this way, we can see, so here's our 3 right here. Just kind of help us visually see that. All right, so from the right, we can see that the function is approaching 4. Our y value is 4 from the right. So y equals 4. However, from the left, we can see, even though there's a little donut hole there, it's still approaching that 3. It doesn't equal 3, but it approaches 3. If it equaled 3, we wouldn't have a function. But this right here is approaching 3. And so, last time I checked, 3 does not equal 4. But in order for the function to exist, it has to approach the same thing from the left and the right. And so the limit as x approaches 3 of f of x does not exist. Now, let me just say that other limits could exist. In fact, 3.5 would exist, but the limit as x approaches 3 does not exist. Okay, so let's look at this next example here. Again, we have a piecewise function that wants to clear up for us. We have a piecewise function, okay? So it says the limit as x approaches 3 of f of x. This whole thing is f of x. So here is 3 right here. I'm squeezing the pimple to see where it approaches. So from the right, I approach 6.3, and from the left I approach 6.3, and from the right I also approach 6.3. So the limit of f of x is going to be 6.3. All right, let's look at the limit as x approaches -2. So here is -2 over here. You'll notice we have a little point right here. That's actually not going to mess with us too much. We're going to look at the function. We're following the function right here as it's approaching from the left and from the right. Now, it does drop down. However, it's approaching that value. It doesn't jump from different ways. It's still approaching the same value from the left and from the right, and that's 5. So the limit as x approaches -2 is 5. It's okay that this is down here. If it were jumpy, like it was up here, where we're approaching from different values on the left and the right, it would be different. Okay, and then finally for our last one, we've got 4. So from the right and from the left, we can see that the limit approaches 7. Okay, even though we know that it's okay, so the limit approaches 7, but just to note, the value of f of 4 is equal to 2. Okay, this is the value, this is the limit. They mean different things. Okay, sometimes they mean the same thing, but they mean different things by definition. Okay, this next part here, I want you to go ahead and try this last part by yourself. Okay, kind of leaked onto the next page, I think. So I'm going to go ahead and write these down here while you're working. Limit as x approaches -3 of f of x and f of. Okay, so looking at this last example here, again, I want you to try it on your own first, but we'll finish it up. Okay, so the limit as x approaches 0, of course I'm cut off. And then we'll just eyeball it, I guess. The limit as x approaches 0 is going to be like -4-ish. The limit as x approaches -3 is probably, gosh, I don't know, -7. I can't see. And then f of 3. You know what? This example is crap. Sorry. Bad example. Because our picture is cut off. So sorry. But you'll have an opportunity to try these in the homework. All right, guys. Pretty easy stuff if you think about it in the way of you're popping a pimple. If your fingers move past each other, you're not going to be able to pop that pimple, so it doesn't work. All right, catch you on the flip side.